Welcome back to my workshop. Over the past month I did a bunch of major upgrades to my 6090 CNC router. Involved quite a bit. I got to do some CNC milling, some 3D printing, and some fiber laser cutting. So yeah, let's go. Okay, here's the current state of my JCut 6090 CNC router. I've used the machine for several years and it works fine, but I'm ready to make some upgrades. There are several things I want to accomplish. One, switching out the Mach3 controller to the Masso G3 Touch like my other machines. Two, upgrading the stepper motors to servo motors. And three, I purchased a used ATC spindle off eBay that I want to install. So let's get started. Okay, so I think to mount the Masso, I have this arm that I took off a monitor stand, and I think I'm going to try to mount it right about here. I attached the back panel of the Masso to the arm with 4 bolts. And here are all of the electronics that need to be removed. I'm replacing pretty much everything in here. Alright, I got everything removed. Now we can see what kind of space I have to work with here. Okay, from left to right, I have the spindle VFD, then a 1.5 kilowatt servo driver, then two 750 watt servo drivers, and then a 24 volt power supply. It's going to be a pretty snug fit. I get all of the components mounted and the power wires attached. Here's the current 2.2 kilowatt water cooled spindle, and the one I'm going to be replacing it with is this 2.5 kilowatt spindle. It uses ISO 20 tool holders, and I think it's got a max speed of 40,000 RPM. Alright, that didn't make too much of a mess. I just need to wire it up still, but the coolant lines are in. Alright, to do the wiring between the machine and the Masso, I have these DB25 breakout boards, cable, and I'm going to run that and any other wires through this to the back of the Masso. Connects to the back of it. 3D printed part. Alright, I got a couple wires here to wire the 24 volts to the Masso, and this one has a 1 amp fuse in it. Alright, that should be good to go. Let's test it here. Alright, the power's on, so let's move on. Okay, let's start wiring up these servo motors. I've got a 750 watt motor for the x-axis. I've got a 750 watt motor with a brake for the z-axis. and I've got a 1.5 kilowatt motor for the Y-axis. Alright, I've opened up all the wires here. So I'm going to hook them all up before I actually install them on the machine and make sure everything's working. With everything else connected, last to do was to solder up these connectors that go between the Masso and the servo drives. I soldered wires to the pins for the pulse and direction signals. Okay, the motors are all wired up, so let me get the software installed so we can test them. I got the software loaded onto a USB drive. I power it on, and then you have to tap the screen quickly to bring up the menu to load the software. Okay, software's loaded. Now I need to put in some settings before I can test the motors. I put in some initial values just to see if I could jog the motors. Then I realized I forgot to wire up the 24 volt connection to the enable pins on the servo drive, so I do that. And finally, I can test them out. I jog all of the motors to make sure they're working, and they do, so now it's time to get them installed on the machine. Alright, I have these 19 millimeter to 10 millimeter couplers to go to the new motor shafts, and I measure the ball screw, and that's 10 millimeters, but my hole here is like the exact same size of this. Alright, let's take a look and see what's in this one too. Okay, so I'm going to just try to use a hole saw to enlarge the holes for the couplers, and I'm using my CO2 laser here to cut out a drill guide to try to keep it from wandering. Alright, looks pretty good. I have a 2-inch hole saw, so we'll see if I can widen that hole. Alright, cool, that should work. Alright, I've got my drill guide set up here on top. Okay, I've taken some measurements and I've ordered some 3/4 inch aluminum bar stock to make some motor mounts, and while I wait for that to arrive, I'm going to take care of some more wiring. I start with making a spindle cable. Then I get the VFD wired up to the Masso so it can control the RPM. Let's wire it up. I have it set at 40,000 RPM. Then I wired up the pendant, and I had to use a step-down converter to bring the 24 volts down to 5 volts. Looks like it's working. You can see the motors turn. And the stop button's working too. Then I get all of the homing switches wired and tested. I'm still waiting on metal, so I go ahead and get all of the air lines run for the pneumatic connections on the spindle. Then I design this bracket to hold the manual tool release button in Fusion 360 using the sheet metal tools. Then I can create the flat pattern to export it to my fiber laser cutter. I get the bracket cut out of 16 gauge steel. I also go ahead and design this bracket to mount the solenoids while I have the laser set up to cut real quick. I don't have enough clearance to make the full bend, so I'm going to finish it off here with a hammer. I get the button bracket spray painted black, drill and tap a couple holes, and get it mounted. Next, I get the other bracket installed and get the solenoids mounted. I also 3D printed some brackets to mount the air manifold and 3D printed a little box for the relay board. I'm not sure where I'm going to mount it yet though. I finished hooking up the air lines, wiring the solenoids and the relays. Alright, I've got my manual tool release button wired up. Seems to be working. The tool. Alright, I got the touch probe all wired up. It just takes this USB-C. And it looks like it's working fine. My aluminum bar stock finally arrived, so I get this motor mount designed for the Z-axis and for the X-axis. I flip the part over and manually bring it down to the correct height. I tap 4 of the holes, and here's the final part ready to install. I mill out a second one for the Z-axis. The Y-axis motor mount needed to be a little bit thicker, so I designed it to be made out of 2 pieces. Okay, the 2 pieces are finished for the Y motor mount, so let's get them installed. Nice. The motor covers no longer fit these new motors, so I designed some extensions in Fusion 360 and got those 3D printed. Looks pretty good. Now 2 more. I designed this riser with an open back for the Z-axis and get that installed. And then lastly, I designed these extensions for the Y-axis motor cover. Next, I installed a tool setter so it can automatically set the Z offset after a tool change, and then I configure the homing routine. Here's the homing sequence in action. Next, I designed some tool holders in Fusion 360 and get those 3D printed. They turned out pretty nice, so I get them installed on the T-slots. Next, I want to do something to cover up all these holes that I left in the front of the machine. So I designed this plate to be laser cut with some extra tool holders that I'll 3D print. Also, while I'm at it, I designed these number labels to put on my tool holders. Here are my laser cut parts. I have all these 3D printed tool holders for the spare tools. I just pre-cut the holes for them. Here you can see there's 3D printed. These numbers are going to go on the actual tool holders up here. I'll just glue them on somewhere. Something like that. Alright, got my wrenches on there. Turned out pretty good. Let me just try some tools in here and see how that works. Alright, that's going to work pretty good, I think. Well, I'm playing with the tool changer logic. Here, I'll let you see. It's working pretty good, but I would like it to take the tool over and do the Z offset automatically after it changes tools. The problem is, say if it picks up a tool here, it wants to go right through the other tool to get there. So I'm wondering, maybe I'll loosen these up and put them all along the side here. That way I'm only losing a little bit of space on my table. and then can always get there without interference. I think I'm going to try that and see how it works. Alright, I've moved all the tool holders over to the side, and I think it works much better this way, so let me get it set up here and I'll show you it working. Alright, so I think I'm calling this project done for now. I've got to do a test cut here and make sure it's working alright, and then I'm going to call it good. I found this little scrap piece of MDF in my shed, so as my first test cut I'm going to surface it to use as my spoil board. The Masso has a conversational program in here that'll be perfect for this, so I'm going to go in here and select face cut and enter my parameters, and then we'll have a file to go. Okay, now I'm actually ready for my test cut. I have this two-part sign that I need to make with a stainless steel front, and then it's going to be mounted to a wood base. So let me show you the cam file for the base. First, I'm going to create this recess with a pocket operation using a 2-flute 1/4-inch end mill. Then I'm going to also go ahead and cut out the contour and leaving some tabs to keep it in place. Next, I'll do a tool change and drill the 2 holes. Then I'll do another tool change and chamfer the edges. Alright, I've got the file transfer over and loaded. I have the 1/4-inch 2-flute, it's tool number 1. Slot 2, I have a 6mm drill bit. Slot 3, the 45-degree chamfer bit. Alright, so everything's zeroed and ready to run. Alright, the dimensions were spot on, so awesome. I'm really happy with how everything turned out, so I guess now it's time to move on to the next one. I picked up this Intelitech Benchman machine that's in really good condition. It's got square linear rails, servo motors, a larger cut area than my machine, and it's got a nicer enclosure that you can use flood coolant with. It doesn't have an ATC, so I might attempt that, and I'm going to add the Masso controller. And I also picked up this flatbed UV printer that I thought would be awesome for printing on acrylic and metal pieces. I got it for really cheap, but I think it's got some problems, so I'm going to see if I can fix it. Thank you to all my Patreon supporters for helping make this happen. I really appreciate you guys. Thanks.